So this is problem number 13 out of the week 10 homework, and of course this is the corresponding problem out of the textbook. So you can get some more practice with this if you'd like. So what I'm seeing, this is about sample means, because I'm seeing an average and a standard deviation. That's what that little symbol means. So what they're asking us is to find the value of the standard score. In other words, so we know that this let's see, I'm looking at HO. They're telling me that the average, the middle, the population, they think the population mean is 80, and that's what HO would say, was that the mean's equal to 80. And then they're telling us for HA, the mean's greater than 80. So they went out, they found us, they did a sample, they found the sample had an average of 83, and we're trying to figure out is that too extreme to say that this is still the center of the sampling distribution. This is back to the central limit theorem. So they're asking us to do this. We're going to do a z-score, and that's what they're asking us to find here. So I know that's the mean. I know that's the sample mean. I need to find the standard deviation for the sampling distribution. So that's where we're going to take the standard deviation for the population and divide it by the square root of the sample size. So I've got 17, and I had samples of size 81. So I'm going to take 17 and divide it by 9, basically. And that's going to be just a little less than 2. Actually, they show us that. Is that right? Oh, standard score. All right. So I'm going to do 17 divided by 9. So that gives me a standard deviation of 1.88888888. So I'm gonna round that to 1.889. That's one more than the decimal place they're asking for, so that should be okay. So now to get the z-score, the standard score, I'm going to take the sample mean of 83. I'm going to subtract the HO number, or the middle of that distribution, population average, what they think it is, then divide it by that standard deviation of 1.889. So that gives going to give me 3 divided by 1.889. So let's see, what's 3 divided by that answer? I'm getting 1.588888. Well, let's see, no, 1.5. 1.588, and then of course that would round to give there 1.59. Okay, so now we're trying to figure out how is that far enough away? Well, I mean, we can use some rule of thumb kind of thinking. I know that's less than 2 standard deviations away, so that's not that big a number, but we'll get some other issues going on here with significance testing. They're telling us the alternative hypothesis. Let's see. Find the value for the standard score. Determine whether the alternative hypothesis is supported at the 5% level. So when we're using these critical value things, it's actually kind of a nice way to do this. Let's see if I can move some of this out of the way. When you're using critical values, and I don't remember if I made a recording about this. This is a one-tailed test. What we can do is, this is anything to the left of that line means we can't reject HO. HO, we can't say that HO is great, that the real mean is greater than 80. So that means we can't reject HO. I mean, we can't say anything about the HA, but anything less than the critical value, this makes HO happy. Okay, because he can't be rejected, or she can't be rejected. If as soon as you get past that critical value, well, that's not a good place for HO. That's what we're saying. But if we got a sample result that big, that if the sample result is that far away from the middle, then must be the middle isn't true, and we're going to reject it. So we need to be able to find that critical value. Now, Dr. Triola made this nice little subset table, and this is on page 380. Okay, and for now, what we have is we have a one-tailed test. I don't know if I can pull this down. Oh, I can. We have a one-tailed test, and it's a greater than. It's a right-tailed test. If you look at my sketch that I made up here, it's to the right of the test statistic. So this is a right-tailed test. A left-tailed test would be over here. So I will always make a little sketch like this when I'm doing significance testing. So I'm going to take a look at my table here. It's a right-tailed test. I'm at a 5% level of significance, right-tailed. So the cutoff for that happy place, or the critical value, is 1.645. Okay. So now to answer this next part of this question, which has this multiple choice thing, and it's telling us that the standard score is less extreme than the critical value. The alternative hypothesis is not supported. So what that means is we did a z-score of what was it, 1.58, 1.59, something like that. That is not as far as it's not to this side of that critical value. It's still in that happy place for HO. So that's why we can't reject HO. The alternative isn't supported, as they're saying. I hope that helps. This happy place thing, sometimes people like it. Sometimes they say that I'm nuts. So I'll let you decide on that.